Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked,
and sometimes what didn't,
you will also hear very personal experiences.
and insights that would trigger your thoughts
And inspire you to do even greater things.
In this episode, Chitra continues her conversation with Matt Genovese, the founder and CEO of Planorama Design. In the last episode, she asked Matt where we begin with writing good stories and how to develop great software. Matt answers that question and also shares a lot of details about working in collaboration with the development team, the challenges in creating APIs, specific challenges in working with hardware that have synchronous issues when you're working on IoT projects, and what failures need to be taken care of and what could be ignored. He goes on to share his experience on the importance of functional verification and how discovery and thinking are also very important along with writing user stories, and how diagrams help all the stakeholders understand and visualize the flow together, and how and when a design sprint happens. Finally, he also shares his message to someone who is aspiring to get into a hardware or a software career. Listen on.
What is it that you've learned or you use in terms of writing effective stories? And when I say stories, I don't only mean user stories, but also the non-functional stories. For example, if there are non-functional requirements that you're looking at, like data ingestion or scalability or performance or response times or throughput.
Sure.
I've seen that a lot of engineers struggling with first the product managers struggling with articulating those requirements and the understanding of those, so that you really have a solid foundation or a backend that can support what is needed
That's right.
upfront. So if there's like 1 million users that's trying to that are constantly accessing the system, it has to be available. It has to retrieve, continuously ingest data, do
That's
some
right.
processing, give responses, especially today where people are probably looking for responses in near real time to take decisions, to decide, let's say, how can I, let's say, optimize my marketing spend? Where should I put in, if I am advertising here, will it give me a better ROI? Stuff like that.
Right.
So
Right.
what have you done to sort of encourage people or write better stories?
Well, that's a good question. And it's funny, you made me think about stories or the work in defining requirements, even between pure software applications and I'll say IoT applications, right? Because there's a difference there as well. For example, from a design standpoint, and I mean design holistically in the engineering sense, what we do is we end up looking at the requirements, looking at what the needs are of the users, the customers, the company, the business, and working with their product manager to prioritize and look for the gotchas, look for where the problem spots might be, the risks, right? Because design is also not only about requirements, but it's also about de-risking, right? And trying to, because that things are going to happen in the future, you just try to mitigate that as best you can. So, in pure software systems, we already have to care about the exception cases, right? And I don't just mean the exception cases like the user types in the wrong information in the UI. The UI tries to guard against that. But what if a service isn't available, like an API, internal API or an external, third-party API? What if it's providing the wrong data back, right? And that is hard enough as it is, because we tend to consider those requirements and spin up projects or mini projects with development, working in collaboration with the development team. Usually our customers, our clients have their own internal development team. Maybe they're working with an external team. We come and come alongside them and say, look, this is what we're seeing. We know that if say this API behaves, or has a performance of a certain level, we can handle the ingestion of the data in the application a certain way. However, if it doesn't perform the way that we expect, then there's going to be a challenge in our UX design, right? In our visual design. And we're going to have to handle that. So then we work with the development team and say, hey, let's put together a proof of concept here, right? And see if we can evaluate how this API, especially if it's a third party where you're just kind of trusting that the manual is correct. We have to get that information and see if the output is indeed performing, or the results are performing in the way that we expect. That is, one aspect of software, I'll say pure software systems that we, end up getting into. And that's, again, working in conjunction with the development team. If you consider IoT projects and hardware, that now becomes the norm. The exception becomes the norm, because not only are you having to care about what I'll call synchronous issues, things that are in lockstep with the user's action. User does X, system responds Y, in sync with them, right? Maybe they receive something on the screen, but now you have potential issues with like servos or stepper motors, going out of position or not functioning. Sensor inputs giving the wrong data, could be giving outlier data, statistically speaking, that like, oh boy, that's going to mess up everything downstream.
Yeah.
How do you detect that? How do you present that? Connectivity, out of service issues, real time safety issues. The software still needs to fail gracefully in some way.
So,
from the
I mean, just listening to you, I think you somewhere have a database of categories and classifiers for all kinds of failure modes.
Well, that's the benefit of working with engineers that are doing design work, right? Because we're engineers are typically the kind of folks that think about the things that can go wrong. And it
almost is giving me this thought, with all kinds of generative AI being so rampantly spoken about and experienced today. What if these were to be given as prompts and say that for this kind of a system, in the path of, let's say, a bit of data, what do you think are the possible failure modes? Okay, and then me as a developer, if I get all of those, I'll make sure that my part of the code is rock solid or something like that.
Well, you certainly, it as I mentioned about Agile, right? We only know what we know now, right? And we try to figure it out, but it's worth it. It's worth that ounce of prevention, to prevent that pound of cure later on. We try to think about, well, here are the things we could anticipate happening. Again, like these asynchronous actions I was telling you about, or behaviors from hardware products, but they can also happen in software too, depending on the other connections. But you try to think through what those are and decide, what are we going to take care of now and what are we going to not care about, because statistically we think it's not going to happen that often. So we consider that, but at least you've thought about it. At least you've made a cognizant decision that we are going to handle these and we're not going to handle these because of the cost or the time constraints. That's completely okay. That's part of the design process and the prioritization of what you're going to work on.
Yeah.
What I try to avoid are the surprises, right? And they're like, oh boy, nobody thought of this happening. And again, there's a lot of things you learn from functional verification, where you run these randomized test cases on your chip or on your model, either within the positive data space or in the negative state space. And you try to find what you couldn't think of, right? It's always those errors those defects that you didn't anticipate that are the ones that get you, right? And those are difficult, and that's an area where I think the software space, they don't always take that into account, right? We're writing test cases to test, the possible things that we can conceive of. How do you handle the things you can't conceive of? And I think that has been largely left out, unless you're in like a real time or a safety critical system where there's guidelines you have to test that.
Yeah.
But I mean, going back to your comments about users, user stories and how they impact customer experience, like these issues I'm talking about, that's an area where, again, design, this holistic design that we do at Planorama and that we, really embody, you try to evaluate what could happen, and then you again make decisions for what you're going to evaluate right now, validate, and then build into your product, and other ones that you might push out, as we'll handle those another time. And so that's where design and development really tend to, walk hand in hand, and as they should. They shouldn't be treated as, separate separate entities. Design is kind of the glue that holds everything together and makes sure that the product has the best probability of being successful in the market.
Absolutely.
So yeah, we're from our perspective, that's what design looks like. It's a lot of those cases. It's also, as I said before, writing all those user stories, writing the test cases as we see it, exception cases, so that the developers and the dev team have what they need to execute, and they can be as efficient as possible. But it does require that you have some level of discovery and thinking. Like sometimes if you speed up too fast and you go into this extreme agile, that's where all the mistakes are made, because nobody's sitting down and really thinking about what all the things that could happen. And
so how do you
does pay off.
So then how do you actually get a cross-functional team sitting? I mean, I'm just visualizing. Do you get to have them all sit around a table where you have developers, you have the test engineers, you have designers, you have product management that's articulating the business cases and so on? Do you start from there, or how do you get everybody to what I like to call see the elephant together?
It's a good question, and it's largely dependent on, like with our clients, it depends on where they're starting from. How much effort that's going to be to get us to see the problem in the same way. We typically label this as discovery, for at least for us, because we have to discover the problem. And the problems or the challenges have to be addressed. However, look, sometimes discovery is as much discovery for the internal team as it is for us. Like we're coming in as the quote unquote external partner, although we kind of roll up our sleeves and we like to, work in the trenches with everybody. We're still oftentimes the new people on the block if we're coming in working with a new client. But however, there are many times the questions that we're asking are uncovering the fact that that question hasn't been asked before internally. And we all need to come together and understand what the answer is to that. And so discovery is happening just as much internally at times as it is external to us. And so that involves, at least the product manager from the, our client. They're typically the ones that understand the space. They're living it day in, day out. The industry, the vertical, the competitors that they have, what other companies are doing. They're going to understand that, and that's an area that we won't, but we're going to be working with them, as a partner to realize that and to help consult them. And then naturally, the development team becomes involved because we start talking about features that we need to understand a bit better how they're going to be implemented, or what the constraints are from the existing system. If they have an application or we're building a new one, we have to understand some things there. So I think the whole process of discovery and asking these questions naturally brings the right people in. And if we don't see them there, we'll usually ask for them. And that, by the way, can be the customer too. I mean, our clients' customers we love to get in front of them and talk to them about their problems using, say, the existing solutions from our client or other solutions as well, and getting their feedback. They're a key part of the process that many times is not always spoken with, right? And
Yep.
And gosh, it'd be really nice to have them involved too. And we don't always get access to them, but we certainly do try. But that discovery process leads us to understanding the problem or problems usually better, and working towards a prioritization. Only when we have an understanding of it and we can start diagramming out workflows and internal data structures and things like that that are going to affect what the user sees and how the application is used, then do we get to a place where we can actually create some screens that we can evaluate together and say, this is what we're thinking. This is how all this discovery information distilled down into, say, a potential user interface that we can start iterating upon.
Right.
Right?
So at this stage, are you using things like, low fidelity prototypes and something that you can very quickly come up with, say, using Figma or
that's right.
So that people can actually visualize together and kind of stitch the flow together? That's
exactly right.
Right.
That's exactly right. When we end up putting together diagrams, using, diagramming software. Actually, Figma has a tool called FigJam, which is like a whiteboard tool. And it's wonderful for just drawing out diagrams, doing sequence diagrams or doing other types that show how data is related. A lot of times we're echoing back to the customer, to our client. This is what we understand. This is what has come out from our conversations, and showing it in a very clear, well thought out, easily understandable, easily adjustable way by everybody who are stakeholders in this process. And then that's how we make sure that we're, as you said, looking at the same elephant.
Okay.
And then from there, the designs flow out. And yes, we do use tools like Figma. Sometimes we do it in low fidelity. Sometimes we just go right to high fidelity because we don't want people to have to look past the back of the napkin drawing version in low fidelity. We find that sometimes high fidelity doesn't take any more effort really, right, but it does help to get past any questions about like, well, what if the button's over here? What if the what if this is like, it doesn't matter.
Yeah,
we have other tools too that we use, is just to try to get those flows worked out and not focus on where things are on the screen, but it does help build consensus, and that's what we're after.
I've often wondered, that in my mind, I visualize it like a stack where the topmost layer is perhaps what the user is experiencing, and then you kind of go down layer by layer. You have an API layer. You may have several API layers, and then you can see how the data is going, where it's going, what's supposed to get returned, and then I always have this grand diagram in my head where it's kind of hard to thinking that we have to get everything right and have it all lined up beautifully, but we know that rarely happens, right? I mean, you do just enough. So I was wondering, do you actually go through an iterative phase for design itself?
Yes.
Like sprints?
Yes, we do. We do, actually. So the discovery, typically, it will take as long as it takes. We don't try to prolong it, but we do, you could call it a sprint, but really we're just trying to understand the problem. But once we have enough information that we can start creating the screens, and we can start basically building the features that we prioritized that came out of discovery, that we all collectively decided, hey, this is what we're going to work on in this, call it a phase of work, or whatever you want to define. Then we go into design sprints, and typically we're meeting with our client at least once a week to review what we have put together and to get feedback from the team. And the people from the client are always the product manager. It can be hopefully the developer, at least one developer maybe the team lead is the best, or a front end and back end. We don't need the entire team to join from the development side, but we're working in a way that we're presenting that the results of what we've done so far in a mid-sprint and an end-of-sprint review, and then we get feedback, and then we turn around and deliver that, say, from the mid-sprint into the end-of-sprint review. We deliver the final designs, have them approved effectively, and then have the user stories written and the test cases written. And so our output from these sprints becomes the input for the development team.
Right.
And,
okay.
And they're working often in their own sprint. So we don't want to disturb them. We let them run their own ceremonies. I mean, typically, every company is a little bit different, but in general, we want them to execute on the work that we've just designed. That is in their backlog, and they've seen it already. They've given comment on it already. It's top of mind. So they're in the best spot then to go and start building it.
So then, have you seen people actually place value on things like design sprints? And do you think that that's a good value proposition to sort of bring to the awareness of companies to say that, hey, it's worth spending time in design iterations so that you can, for example, effectively actually reduce your time to market or produce better quality software? Have you had the opportunity to position it that way, or what are your thoughts on it?
Well, I think there's a nomenclature issue. So when I say our design sprint, I'm really saying just a UX sprint. We are. I know there's a lot of baggage, or a lot of, I say baggage, but there's a strict definition that many people use for design sprint with a capital D and a capital S, where they're trying to, what I think is do a lot of discovery work in that particular sprint, and come out with something. And it tends to be very, very intensive. We break that up. We effectively spend a lot of that work in what I'll say is discovery. In that set of time where we're trying to understand the problem and determine the right solution, and the workflows that are associated with it. And then our what we call our design sprints, or maybe with a lowercase d, or a UX sprint, is really the execution of it, right? The execution say, okay, we're going to take these features that we've already determined with these workflows, and we're going to design the screens for those. And then the output of that UX sprint is the design or the designs with the user stories and the test cases that are now going into the backlog for the development team in their next sprint. So it's not the same. It's a shame, because design sprint has become this term that kind of like everything else in software, it's overloaded terms. You have to define which one are you talking about. But I mean it in terms of a very tactical, get the requirements written, the visual requirements and designs written and out so the dev team can execute.
Yeah. So what I had meant is I think the discovery phase is that you've nailed down the problem, and then that itself takes a few iterations.
It does.
But towards the end of it, both parties know that, okay, now these people are going to go off and actually have prepare the screens, elicit the requirements so that we can get started with dev work. So basically the rework, if I may say so, is minimal thereafter.
That's right. You've nailed it. That's exactly right. It's all de-risking, right? The entire process, right? If you walk in and you say, we're going to start designing screens, it takes time to do that. Yeah. Right. And it's time that our clients are paying for. And if you have to go back and redo those screens, you're paying for that. That money was wasted. We'd rather draw diagrams that are very quick to understand, quick to build, and for us to all agree that, okay, this is the right workflow, this is the right organization of data and information. The dev team has given comment, the product team, customers for that matter may have given comment, whoever is involved from the stakeholder, they have all reviewed. And now when we're designing screens, we have a really good feel for what needs to be there. And now we're implementing those workflows using well understood design patterns and heuristics, and with a solid grasp of how the information architecture is formulated for this application. And now there's, again, rework could happen in the future, and that's always a possibility. Agile does its best to prevent it, but it doesn't mean it's promised.
Yep.
But we really try to de-risk it so that it does not, it is likely that those screens are going to be correct based on all the information that we uncovered earlier. And therefore, when the development team receives it and they're building those screens, again, we don't want to run into a case where we couldn't anticipate something that came up, although it can happen, that would require, complete redesigns of screens or areas. We really try to avoid that, right? We build for expandability, extensibility in the future, and really try to avoid painting ourselves into a corner through our designs, and because we know it costs money. It all costs money, and we want to give our clients the best bang for the buck.
Right. Okay. As we come towards the end of our podcast, we usually ask our guests to leave listeners, and particularly those aspiring towards a career in technology, software or hardware, with a message. So what would you like your message to be, Matt?
Oh boy. Well, I'll say probably two things that come to mind. One of them is to just remain curious. And I know it's almost cliche, like you expect to see it on a cat poster, but it's really true. There's a lot that's changing today. I mean, I don't have to bring up artificial intelligence, the proliferation of that. That is going to change a lot of areas that I don't think a lot of people even either don't realize, or we can't fathom the way it's going to affect certain areas. But what you can do is stay curious about how it works, right? If anybody's concerned about what's going to happen in the future with our jobs or with economy, for that matter, the economy, it behooves yourself to at least be curious enough to jump in and understand it better now. It's better to be at the front of it than the back end of it, I think. Okay. And that goes with anything, AI, whatever.
Yep.
The other thing I'll mention, and it's kind of a separate topic, but one of my favorite quotes that I think goes back to Voltaire or Montesquieu is that perfect is the enemy of good. We typically tack on good enough.
Yeah.
Engineers, and I have to check myself on this too, by the way, I'm not immune. Engineers tend to want perfection. Engineers, when they're developing code, that nobody likes technical debt. Nobody likes the fact that it's not really built the way I wish it was. It can break. There's a problem here. Its upgrade path is going to be terrible, this or that. And the problem is that our customers need to have solutions built. And businesses need to make money and things like that. And so we have to be careful with the perfect. And by the way, even in design, it's the same thing. Right?
Yeah.
Design is not perfect either, but you do the best with what you have. And doing the best does not mean that it's perfect. It means that it's good enough to get it out, to get people using it, to get it tested, to start generating revenue from it. And then you can go back and refine it from there. But I know engineers in particular are often after perfect. We always learn the theoretical in college, and like, oh, this is how it's supposed to work, you know? And then you don't like, oh, there's inertia and there's wind resistance and there's this and that. Like, oh, that messes up my perfect equations. So the same goes in the business world.
Yeah, no, in fact, it goes back to what you said earlier when we were talking about anticipating all adverse events, right? I don't think there's a point where, like you said, you can list all of them, but if you've covered the critical ones where you don't land up with a severity 1 defect after you've shipped the product,
that's right,
and you can anticipate that, that's good enough, right?
You do the best you can with what you have.
Yeah.
Right. I think that's probably a phrase we should use in life, and probably it might assist us in having to go to a lot of therapy as well. But it is the truth. You do the best with what you have. Perfection is not attainable. So we have to figure out what is the right path with the information that we have right now, and do the best with it we can, and mitigate the risk as much as we can.
Oh, okay. So I've really enjoyed this conversation, Matt. Thank you so much. For me, it was actually getting an overview of the process, the way in which you do what you do, and obviously why you do it. So I want to say a very warm thank you from all of us here and myself at the Software People Stories for your time and sharing insights into your experiences, as well as like I said, the way you do things for clients, and looking at de-risking. I think that's the one thing that I'm going to be taking away from this conversation. So thank you very much.
Thank you, Chitra. It was very nice to meet you, and I tell you, the time we spent, I had to look at my clock, and I thought, my gosh, the time really flew by. So I really had a wonderful time. Very lovely to speak with you, and enjoyed our back and forth.
Thank you so much. Thank you. We thank Siddharth for the music and Anita for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.